Right. So good morning, everybody. So I think last class we are done with the continuation of what is called as your the proximity sensors, right? So now we'll proceed further from there and we'll try to understand the different types of the proximity sensors. Okay, right? I think can able to see?
Yes, sir.
Yeah, good. Okay. I think this we have finished, I hope, correct now? All effect sensor we have finished, correct? Yes or no?
Yes, sir.
Right? Okay, all effect sensor we have finished. Okay. And then we understood the figure diagram and the equation. Okay, that is VH proportional to BI by T. And also the application point of view we have discussed. Then we went to proximity sensor. Then the proximity switches we have discussed. Then the eddy current proximity sensor. And then next we have discussed the pneumatic proximity sensors. Okay, right. Okay. Now we'll move on to what is called as the fourth one, called as the capacitive type of proximity sensors. Okay. Now in capacitive type proximity sensor, okay, now we'll just go with this. Okay, right. Now in the fourth one called as the capacitive type of proximity sensor. Now we are going to consider what is called as the basic principle of the capacitance. Okay, if you know, the capacitance is nothing but what? Capacitance is nothing but the capacitors are the devices which are mainly used to store the charges. Correct, right? Capacitors are the devices which are mainly used to store the charges. And using that concept, okay, of capacitance, we are going to develop what are called as the proximity sensors. Okay, we are going to develop what are called as the proximity sensors by understanding the concept of capacitor. Now what we have understood now is, okay, now we have what is called as right. Now I'll just go with this. Okay, other than this I will directly present Can you able to see something on the screen? Hello?
No, sir.
What is that? What is there on the screen now?
Nothing, sir.
Nothing?
Yes, sir.
Is that white page is there?
No, sir.
Okay, one second. Now?
Yes, sir.
Yeah. Okay. Am I able to see what is it I am writing?
Yes, sir.
Yes, sir.
Huh?
Yes, sir.
Yeah. Okay, right. Now we'll go with what is called as the capacitance type proximity sensor. Okay, so I'll just try to use this method. Now I told, okay, we have what is called as capacitor. What are capacitors? What are capacitors? Tell me quickly.
Those are the charge carriers, sir.
Okay, they are called as the charge carriers. Okay, they are called as the charge carriers. That is nothing but capacitance. Okay, so capacitance C of a capacitor. Now we know the basic equation. What is the basic equation of capacitance? Any idea? What is the basic equation of capacitance? Anybody? Epsilon naught, epsilon r A divided by D. Okay, right. Now what we know is that if we are going to separate two plates, okay, if you remember this, if you are going to separate two plates by what are going to be called as the what is this? This is plate number 1 and this is plate number 2. And if you are going to separate by what is called as the dielectric media. Okay, so we can separate by a dielectric media. Okay, right. So we develop what is called as, we can able to develop what is called as the capacitance. Okay, so this is the basic principle. Now, in this basic principle, okay, it depends upon the capacitance is going to be depends upon the plates, the type of the dielectric media, and the distance between the plates. Now, here you understand that the capacitance will be equal to epsilon naught epsilon r A divided by D. Now, what is where? What is epsilon? What is epsilon here? Is what is epsilon? Permittivity. Permittivity. Please note down this. Some mathematical equation is there. That's why I'm using this method today rather than the PPT. Permittivity of the free space. What is free space here? Free space is nothing but the air. Okay. Epsilon r is what? Epsilon r is relative permittivity. Can you able to see that what is that I am writing clearly?
Yes, sir.
Okay, okay, good. Relative permittivity of dielectric material. Okay, right. Then what is A? Any idea? What is A here? What is A?
Area
A,
between those two plates, sir.
okay, area of overlap. Okay, area of overlap. Okay, what do you mean by area of overlap? Means now if this is one plate, okay, and if I am going to consider this as the other plate, now if you just have this, okay, so this is called as the area of the overlap. Similarly, like let me take, okay, this is one plate and the other plate is only this much. Okay, other plate is like this. What is the area of overlap? The area of overlap is going to be from where? From this point to this point. Are you understanding now? So this is the area of overlap. Okay, right. Then what is D? D will be equal to what? D will be equal to distance between the plates. Okay, distance between the plates. Okay, right. Now this distance and this distance is called as D. Okay, are you understanding? Or this distance is okay, no issue. You can take this also as D. Clear now? Okay. Is this parameter clear to you first of all? Okay. Yes or no? Clear?
Yes, sir.
No. Okay, right. Now, this is the basic principle now. Okay, so this is the basic principle of the capacitance that you are going to get. Now, how to use, okay, how to use this principle, okay, for proximity sensor is the question. How to use this principle for proximity sensor is the question. Okay. Now we know we are not even started to understand the capacitance type proximity sensor. Now what we understood now is we understood what you mean by capacitance. Capacitance C will be equal to epsilon naught epsilon r A by D, and we know this is the thing, and we understood A. Okay, and then we understood what is called as D. Now, by having this concept of capacitance type of the capacitance, we'll try to understand how to build the proximity sensor. Okay, before that, what do you mean by proximity sensor? What are we detecting here? We are determining what is the amount of distance moved. Are you understanding? We are determining what is the amount of distance moved. Okay. Now, by using this concept, we'll try to determine, okay, so we'll try to monitor what is called as, okay, monitoring what? Monitoring the linear displacement. Okay, this is what is very, very important. Okay, so we are interested to monitor what is the linear displacement. Okay, linear displacement is nothing but what? It is nothing but what is called as the proximity. Checking up of the proximity is linear displacement. Okay, now what I will do is, now you know, okay, so this is one particular plate. Now we'll try to draw the various forms of capacitor. Okay, now this is one particular plate. Now we have one more plate now. Okay, right. Now what I will do now is, okay, I know this is going to be, let's take from bottom plate to bottom plate as what is called as D. Okay, and this, you know, this is, what is this now? What is this I wrote? This is called as what?
Yeah.
A. This is called as A, and we have a dielectric media. Okay. Now what I will do is I will move one of the plate. Okay, I will move one of the plate in y direction. Okay, move this plate in y direction. Okay. Now what is going to happen now? Now we have what? We have C is equal to epsilon naught epsilon r A divided by D. Correct. What has happened to this now? What has happened to this? D, ds. I am moving now. I am moving in a sense what? I am giving the displacement. Okay, what is going to happen to this D? What has happened to ds? Increased. Correct. Okay. Now, once the ds increased, what is going to happen to your value of C?
Decrease.
Huh?
Decrease.
Decrease. Okay, now C is going to be reduced by something that becomes C minus delta C. Are you understanding? That will be equal to, this has come. Okay, the reduction in the capacitance is occurred because of what? Because of what is called as D increased to D plus X. Okay, so this is one method. Correct now? Now what has happened now? The amount of reduction, amount of reduction of del C, reduction of C is directly proportional to what?
Yeah.
Huh? A na. In this case. No, it depends upon what? In this case, in this condition, the amount of reduction of C is proportional to what? These are all the constant. This is constant. This is constant. This is constant. What is that I am changing? I am only changing the value of distance. Okay, so amount of reduction of C is proportional to what? Proportional to the distance moved. Yes or no? Right. Now this is one method. What is the other method? What is the other possibility? The other possibility is what? Okay, the second one is, what I will do is, observe. Okay. Now the second one is, okay, I will move the second case. Second case is, now I have one plate here. Okay, right? Now this is the basic thing for which C is equal to epsilon naught A divided by D. Okay. Now what I will do, now this is the value of A now for this condition. Correct? For this condition, this is the value of A. Now I will move this plate. Okay, I will move this plate in X direction. Are you understanding? Okay, X direction movement. Okay. Now what has happened now? So this is as it is. So this is as it is. Okay. Now I'll just move this plate. Okay. Now this is going to become like this. Now what is going to happen to the area of overlap? Will it increase or reduce?
Reduce.
Reduce. Okay. Now C is equal to epsilon naught epsilon r A. Okay. A is going to reduce D. Okay. Now, are you understanding what I am telling? Okay. If you reduce the value of A, what is going to happen to the value of C?
Decreases, sir.
Correspondingly decreases. That means now here, this is constant, this is constant, this is constant. Correct? So this is nothing to do with the equation. This is nothing to help, and this is nothing to help. Only thing is what? Only this and this are the parameter. That means amount of reduction. Okay, amount of movement. Correct? Of what? Amount of movement of plate in x direction leads to what? Leads to reduction of what? Reduction of area of overlap A, which in turn leads to what? Which in turn leads to tell me, which in turn leads to reduction in
capacitance, sir.
reduction in
Capacitance.
capacitance, reduction in capacitance. Okay. Now, what is that you are determining? You are determining the capacitance. Okay. Okay. Through what? Through the movement of plate in x direction. Yes or no? What is this movement of plate in x direction can also be called? It's also called as what? Also called as the displacement. That is nothing but what? How much you have moved. Okay. So that is the basic principle of the proximity sensor. Okay. Now the third case, what is that I am doing now is, now what I can change now? So in the basic equation, what is that I can change now? What is Okay, so this is C. Again I am writing AD. Okay, right. Now, have we changed A already? Have we checked with A? Change in A already we have done in the second case. Change in D I have done in the first one. Okay. Now between epsilon naught and epsilon r, which can be changed? Which is the changed? Which can be changed parameter? Epsilon naught can be changed. Is epsilon naught can be changed?
No, sir.
No. Why? It's a constant. It's a constant, which is the permittivity of the free space. Permittivity of the free space is the air. Air is the free space that is constant because you are kept the plate in the air. That is finished. So only thing what you can change now is epsilon r. What is epsilon r?
Relative permittivity of dielectric constant.
Dielectric media. Okay, relative permittivity of the dielectric media. Now what I will do now is, okay, now we have dielectric media like this, correct? So the whole of the plates is covered with, between the plates, it is covered with the dielectric media. Now what I will do, I will make some system. I'll keep everything same. Okay, A is from here to here. Okay, A is same, D is same. Yes or no? Yes or no? Okay, right. Now what I will do, I will only have the dielectric to be present only like this. Yes or no? Clear now? Okay. The dielectric is going to be, I will push the dielectric to be present only in this area. Okay, I will make sure that the dielectric is only present in this area. Here, I don't have any dielectric material. Therefore, what is going to happen to relative permittivity? The relative permittivity is going to be reduced. Once the relative permittivity is going to be reduced, okay, reduction in what now? Reduction in relative permittivity. Relative permittivity. Okay. That means what is that? What is the reduction relative permittivity means what? This area, this distance I have reduced. Okay. So that is nothing but the concept of proximity sensor. Okay. Now in these cases, in 4 cases, we have done what is in these 3 cases, we have developed the other 3 forms of the capacitance sensor. In the first case, what have we done? One of the plate we have moved in the y direction. Correct? Movement we have done. Okay. So that movement is nothing but the proximity of the object. Okay. How much you are going to move? That is going to be measured in the form of capacitance. In the second one, how much I have moved the one of the plate in the horizontal direction. Okay. Is it earlier it was something? Okay. How much you have moved? Depending upon that, your value of capacitance changes. Okay. So by observing the value of capacitance, you are going to know what is the amount of the plate which I have moved. Okay. Are you understanding clearly now? Getting it or what?
Yes, sir.
Yes. Are you
Yes,
getting
sir.
it? Okay, right. In the third case, what is that I have moved now? Is it I have moved the plate in y direction?
No, sir.
No. Is it I have moved the plate in x direction?
No, sir.
No. Okay. So both A I have not touched and D also I have not touched. But rather, what is that I have moved? I have moved the dielectric media itself. Means I have removed the dielectric material from some portion of the plate. Therefore, the presence of the dielectric media has been reduced or increased.
Reduced.
Reduced. Okay, so how much amount reduction is going to occur? That will be shown where? That will be shown in the value of your C. Are you understanding? So changes in the value of C is a measure of what is called as the distance. Okay, now this is one particular thing that is going to be present. Okay. Now just next stage we'll go through. Okay, right. Now what have we done now is in the first case. Okay, in the first case, we have moved one of the plate. Okay, we have moved one of the plate in y direction. Okay, by an amount equal to x. Okay, so this was your D. Okay, this was your D. Now, what is my basic equation? What is my basic equation? My basic equation is what? C is equal to epsilon naught epsilon r A by D. I'll call this as equation number 1. Okay. Then by making this to happen, okay, by considering one of the plate, please understand carefully. If the separation between the D is increased by an amount equal to D plus X, okay, then the capacitance equation becomes what? Due to this, what is the capacitance equation is going to become? C will become what? C What is one? Is it C plus or C minus?
Minus.
C minus. Okay, how much? I don't know. Let me say change in capacitance delta C. Okay, that will be equal to epsilon naught change. What about the numerator? Numerator is same or same. Okay, so then D is going to become what? How much you have moved? How much you have moved? You have moved by an amount equal to X. Yes or no? So it becomes D plus X. I'll call it plus 2. Okay. Now we'll calculate what is the change in capacitance. Okay. We'll calculate change in, hence, change in capacitance to original capacitance. Okay. What is change in capacitance? What is change in capacitance? Delta
C, sir.
C. Original capacitance is C. Okay, now we'll calculate this. So now what shall we do now to get this? We'll divide 2 by 1. Okay, all of you make a note of this and do some calculation in your book. Okay, right. So C minus delta C divided by C. So what is going to happen now? Epsilon naught or A by D plus X into D will go above D divided by epsilon naught A. Okay, right. So now if I take, so this will get cancelled. 1 minus delta C by C. Correct? That will be equal to D divided by D plus X. Okay, right. What we want now is we want delta C by C. Okay, right. Is it clear up till here? Any doubt? Shall I proceed to the next page?
Yes, sir.
Okay, so this is my second page. Okay, so let me go to the next page. Okay, okay, right. Now what is my delta C by C now? Okay, I'll send delta C by C onto the right side. So 1 will be here only. 1 minus D divided by D plus X. Yes or no? Clear? Clear or what?
Yes, sir.
Is it clear?
Yes, sir.
Any doubt?
No,
Yes or no? Okay, right. Now, what is the change in resistance? What is the output here? What is the output? Output is change in capacitance. Correct or what? What is the input parameter? What have you changed? What have you changed?
distance.
Distance. That is in, what is distance is nothing but X. Yes or no?
Yes, sir.
Okay. Understanding, right?
Yes, sir.
Okay, right. Good. Now output is going to be delta C. Input parameter is C. Now, where the delta C is going to be? Delta C is going to be in the numerator. Okay. X is going to be in the denominator. Yes or no? Okay.
Yes, sir.
Now, what is going to happen is with the increase in value of X, what is going to happen to delta C?
Yes,
Tell
sir.
me. Decrease. Increase in value of X, delta C is going to reduce. Okay. Now this is going to be what is called as the non-linearity. Okay. With the increase in one parameter, other parameter is going to reduce. Okay. Non-linearity exists. Are you understanding? If there is going to be non-linearity, this non-linearity will give rise to, okay, will give rise to what is called as non-linearity error. Okay. Anywhere have you discussed this non-linearity error? Where have you discussed this non-linearity error? Where have you discussed non-linearity error?
Control system.
Yeah, okay. In the case of the performance terminology of transducer, if you remember, we have started with what is called as the accuracy. What is that range? Please try to recollect range, span, accuracy, precision, hysteresis error. After hysteresis error, we have discussed non-linearity error. Okay. Now, is this non-linearity error is good to have or is it bad to have? First of all, shall we have non-linearity error or shall we not have non-linearity error? You require this or you don't want? The concept is nothing but the name itself says it is error. Okay. So error to be what? Error to be reduced. Okay. Therefore, what you have to do now is this you have to convert it into what is called as the linearity error. Okay. So you have to convert to linearity. This non-linearity you have to convert to linearity. Therefore, now for this, have you understood up till here? What is the problem now? What is the problem? The output delta C is inversely proportional to X. That is, the change in capacitance delta C is non-linear to the displacement X. So this non-linearity has to be reduced. Okay. So to remove this non-linearity, okay, right? We use the new one called as push-pull. Okay, push-pull type capacitor, proximity capacitor, or we use differential capacitor. Okay, right. So this is the one what we are going to use. Okay, now what is that we'll be having now is we'll have, understand carefully, we have one plate. Okay, right? Then there is one more, please note down this, there is one more plate and we have one more plate now. Okay, how many plates are going to be now become now? Earlier, how many plates were there? Earlier, we used to do with only 2 plates. Now, I will maintain this as same. This is going to be my value of D. Okay, and the same value of D is going to be from here to here. Okay, right. I will give the central one some displacement. Try to understand carefully the central plate. Now, how many capacitance that you are going to get with this? How many capacitance you are going to get? With this combination, how many capacitance you are going to get? 1 or 2 or 3? Huh? How many?
2.
Huh?
2, sir.
2. Okay, one is called as capacitance C1. Okay, that is the top one and the middle one will form one set. The top one and middle one will form one set of the plate, and we have capacitance C1. Then subsequently, the middle one and the bottom one will have another plate which gives you capacitance C2. Okay. Now, so this is the new arrangement what we have made. So this new arrangement is what? This new arrangement has 3 plates with the upper plate and the middle plate forming one capacitor, and then the middle plate and the lower plate forming another capacitor. Okay. Now what has happened? Now I am giving the displacement to what? The middle plate. When I give the displacement to middle plate, what is the action that you are doing for the top one? Now we have push pull. Okay, what is that you are doing out of this push and pull? For the top one, what is that you are doing? The middle plate you are pushing or pulling?
Pulling.
Huh?
Pulling.
Hey, just observe the top one here. The top one, okay. Consider only this one, consider only this case, top plate. Okay, if you consider top plate, are you pulling the capacitor plate, or are you pushing the capacitor plate, middle one?
Pull, sir.
Okay, I think you're not understanding the basics only. I don't know. Okay, right now here we have only 2 plates. Yeah. Okay, consider only 2 plates. If you consider 2 plates, push is nothing but what? Push is nothing but you are moving. Push is nothing but you are sending it away or you are taking near to you.
Taking near.
Push means what? Push.
Away from.
Away
Okay,
from.
your push means what? Okay, push means you are making this D to increase or D to reduce. Tell me at least this.
Reduce.
Eh,
Increase, sir.
the top plate I am asking. In the top plate, if you push this X downward, If you push this x downward, are you increasing the value of d or are you reducing the value of d?
Increase.
Increasing the value of D, sir.
Okay, means you are pushing or you are pulling.
Pushing, sir.
Yeah, simple. Okay, you are pushing the thing. Then come to the down one. Then come to the lower plate. In the lower plate, you have D. D is going to reduce or increase now.
Reduce, sir.
Reduce. Okay, once the D is going to reduce, is the middle plate is coming towards the lower one or going away from the lower one?
Coming towards the lower one.
Coming towards. It means what? Push or pull.
Pull, sir.
That's a simple. Okay, now the name of the capacitor is push-pull type of the capacitor. That means by moving one of the plate downward, you are pushing in one capacitance, and in the other capacitance, you are pulling the other. Okay, that is called as the push-pull. Okay, right. Now with this, what is going to happen to the C1 now? Tell me now. C1 is going to become what now? C1 is going to be earlier what? Right, please understand. Earlier C is equal to epsilon naught epsilon r A divided by D. Okay. Now we are giving the displacement to what? Which plate you are giving the displacement?
Middle.
Central plate. Okay, middle plate. Middle plate. One second. Middle plate, I am giving the displacement. Okay, when you move the middle plate, central plate, the capacitance C is going to become C1. Okay, C1. Epsilon will remain same. Epsilon R will remain same. A will remain same. Then D is going to become D plus X. Correct. Similarly, what is going to happen to C2 because of this? Madam, class ಅಲ್ಲಿ ಇದೀನಿ madam. Okay, so middle plate is epsilon naught epsilon r A, denominator D
minus x.
D minus X. Okay, so this is the two things which are going to occur. Okay, now just observe. Now what I will do now is, okay, is this up till here? Is it clear? Any doubt?
No, sir.
Okay, right. Now I have got C1 and I have got C2 now. Okay, now I will do one thing. C1, okay, I will make C1 will become one arm of AC bridge. Okay, this gives you what? This gives you E1 voltage. Now just observe. Now I want to measure the difference in the voltage. C1 will become one arm of the AC bridge, which will give E1 voltage. C2 will form another arm of AC bridge. What is the voltage which gives now? The voltage which gives you is E2. Okay, now understand carefully. Okay, E2 is the voltage. Okay, now we have capacitor C1 and we have capacitor C2. We have capacitor C1 and we have capacitor C2. Now I will do one thing now. C1 I will form one arm of AC bridge, and C2 I will make another arm of AC bridge. Due to this, E1 is the voltage and E2 is the voltage developed. Now, what is the net voltage that I am going to get now is, what is the net voltage? Just observe the output voltage. Okay, we'll go to the fourth number. Output voltage. Okay, output voltage E will be equal to, okay, or you can say resultant voltage. Please note down all this. Okay, resultant voltage E will be equal to E1 minus E2. Okay, right. Okay, now we'll calculate what is E1 and E2. Okay, now for AC bridge with E1 and E2 as two arms. Okay, E1 will be equal to, okay, please note down, E1 will be equal to E into C2 divided by C1 plus C2. Okay, so this is the equation. Please understand carefully. E1 will be equal to E into C2 divided by C1 plus C2. Okay, all of you just do this mathematics. substitute, we'll try to understand what is E1. Substitute the value of C1 and C2. Substitute the value of C1 and C2. Okay, now you do me, tell me what is the value, tell me, do it off. E into, what is C2? Tell me, what is C2? What is C2?
Epsilon naught epsilon R A by D plus
Ah, D?
D minus X.
D minus X. Okay. What is C1?
Epsilon naught epsilon R A divided by D plus X.
Okay. Plus epsilon naught epsilon R A divided by D minus X. Okay. Right. Solve this equation. Okay. Right. Observe. Epsilon naught epsilon R A. It is constant. I will take out this. Okay. So what is there here? E divided by D minus X. Okay. Right. So what is the LCM? D plus X into D minus X. Okay. Right. So what is going to happen now? Okay. Tell me. D plus X will go. It becomes what? Numerator D minus X. Yes or no?
Yes, sir.
Okay. Plus D plus X. Correct or what?
Yes, sir.
Okay. Right. Now D minus X will goes away. Minus X plus X goes away. So E1 will be equal to what? E divided by E into tell me what is E1? Work out and tell me. Yeah, Mithun.
Sir, E into D plus X divided by 2D, sir.
E into D plus X divided by
2D, sir.
D. Okay, so that is the value of E1. Okay, right. So you similarly, okay, right. Now E2 is going to become what? E2 equation E2 is going to be, earlier it is what? Earlier it is, now if you observe, E into EC2. Okay, E into EC2. Therefore, for E2, what is going to come? E will remain as it is. In place of C2, it becomes C.
C1, sir.
C1 divided by C1 plus C2. Okay. So substitute into this equation and give me the value of E2. Substitute the value of C1 and C2 to this equation and give me the value of E2. First, quick. Okay. So E into C1 is epsilon naught RA divided by D plus X divided by epsilon naught epsilon RA divided by D plus X plus epsilon naught RA divided by D minus X. So constant is epsilon naught epsilon RA, that I have taken it off. Okay. So it becomes E divided by D plus X. In the denominator, if you take LCM, D plus X into D minus X. So we have D plus X will go away. It becomes D minus X. Okay. Yes or no? Yes.
Yes, sir.
Okay. Then it is plus plus D plus X. Excess goes D plus X. So E2 is going to become what? E2 will be E into
E into X divided by 2D.
E into
D minus X divided by 2D, sir.
2D. Okay. Right. Okay. Right. Now, what is the value of output voltage now? Okay. We'll go to the 5th page. Okay. Right. So, what is the value of, to calculate the value of E now? Calculate the value of E. What is E? What is E? Tell me E.
E1 plus
E
E2
is
minus E2.
huh?
E1
E1
minus
minus E2. Okay, right. What is E1 now? E into D plus X divided by 2D minus E into D minus X divided by 2D. Correct? Right. So we'll take what? We'll take E minus 2D common. So it becomes D plus X. So minus is there. Minus into minus plus X. Okay. So D and D goes away. So we have E is equal to E divided by 2D into X plus X, 2X. So therefore, E will be equal to what now? E will be equal to E into X divided by D. E is nothing but what here? Difference in voltage. Okay, right. Is this clear to you first?
Yes, sir.
Okay, now you understand. What is E1 minus E2? E1 minus V2 is what? Output voltage. Yes or no? Output voltage E will be equal to, output voltage will be equal to E into X divided by D. Okay. Now, what is the relationship? What is the relationship now? Okay. Now, what is that we have done earlier? We have got what? We have just observed delta C by C will be equal to 1 minus what? D by D plus X. Correct or what? This is the thing. So delta C is the output. Correct? Understanding? X was the input. X was the input. Okay. Now the problem was what? Problem was non-linearity. Correct or what? Now this non-linearity, what have we used? We have used push-pull type sensor. Are you understanding? And we have come out with output voltage E will be equal to E into X by D. So output voltage and X. Now what is this now? Is it non-linear or linear?
Linear.
It is linear. Okay. Now this is the purpose for which we have done this exercise. Okay. Now this is how to convert non-linearity. Okay, how to convert non-linearity into linearity. Okay, is it clear now? Okay, so this is one type of sensor. Okay. Now other type of sensor is going to be the last one. Is what I will do is I will have one more plate now. Okay, right. So this is one plate. Okay, this is a capacitor plate. This is a capacitor plate. So this I will call it as sensor. Okay. Then one more is this is the object. Object. What is the object I have done? Object is fixed object. Okay, and I am going to earth this. Okay, right. Now the question is, this is another type of capacitor, capacitive proximity sensor, where we have only single plate now. Okay, earlier what we used to say that there should be two different plates which constitutes the capacitor. But now here we have made only one plate, and I will move this plate downward. Okay, when I move this plate downward, what is going to happen? What is going to happen now? What changes?
D changes.
D changes. When D changes, the capacitance C changes. Okay. And if I take this away, the value of C is going to be again changes. That means when I push the one of the plate nearer to the object, are you understanding? If I push one of the plate nearer to the object, the value of D will keeps on reducing. Okay. For all reduction in value of D, what is going to happen to C? C will
Increase.
increase. Are you understanding? If you are reduced by 1x, C will correspondingly increase. If you are reduced by 2x, C will correspondingly increase. Are you understanding what I am telling? Right. So this can be considered as one of the capacitive sensor. Okay. Right. Now, what have we discussed is the different types of capacitive sensors. So now there are three cases to summarize. We have what? C is equal to epsilon naught, epsilon r A divided by D. That was the basic equation. So three forms of capacitors we have done. Okay, three forms of capacitors we have done, wherein we have changed it to what? We have changed the distance d in one case. Then we have increased we have reduced the area of overlap, and then we have changed the dielectric media. Then what we understood there is in one case the nonlinearity error is going to come. In order to reduce the nonlinearity, we have developed another sensor called as the push-pull type of the sensor, and some mathematical equations we have done, and we understood the output is going to be proportional to x, because that means non-linearity we have converted into linearity. Okay, then finally we have come out with one more case. Okay, that is only one plate can also be made as the capacitor. Okay, so this is something related to the proximity type, capacitance type of the proximity sensor. Okay, then we'll move to the next page. Okay, right. Now just observe. Now the next one will go. Okay, so that is the 6th page. Okay, so it is, you know, done. It is called as photoelectric proximity sensor. Photoelectric proximity sensor. Okay, right. In case of photoelectric proximity sensor, what is the input source? Can you say? What is the input source?
Light. Light.
Light, sir.
Light. Okay, photoelectric light is the input source. Okay. Now here we have two methods. One is called as, under this we have two methods. One is called as reflective type. Okay, reflective type proximity. Okay, right. Now how this works is simple. In reflective type we have this setup. Okay, so we have what is called as LED. We have what is photo detector. Then we have the object. Okay, right. Now just observe, this is the object or the target. Okay, right. What is the purpose of LED? Now this method is called as reflective type proximity sensor. Okay, so this method is called as reflective type photoelectric proximity sensor. Okay, what is the function of LED? What for LED is used here?
Input to the
LED is used. What is LED? LED is the source of light. Okay, it emits the light. When the light is emitted, it falls on where? It falls on the target. Or no? Right. Then the target, what it does? It reflects the light. Target, what it does? Target reflects the light. Which is the one which detects this light? The target, the deflected light will be reflected back to where? The photo detector. So what is the function of LED now? The function of LED is to emit the light, correct? It's a light source. The function of photo detector is to
detect the light.
Is to receive the reflected light. Now observe, now I will move the object closer now. Okay, so this is my object now. When I move the object, what is the time taken for the photo detector to receive the light? Will it be more than the previous or lesser than the previous? Lesser than the previous. Now what is that you are trying to do is, when you are moving the object, it means what is that you are doing? You are displacing. Yes or no?
Yes, sir.
Okay, when you displace the object nearer to the sensor, the amount of time taken by the photo detector is small. Similarly, if I move the object here, assume if I move the object here, what is the amount of time taken by the photo detector?
More.
Okay, that means to say the amount of time taken by the photo detector depends upon what? Depends upon what?
Time.
No. Depends upon what?
Distance.
Okay, depends upon distance of the object in front of the LED. That's correct or what? If the distance is going to be nearer to LED, photo detector will receive the reflected light faster. Okay. If I move the same object away from the sensor, photo detector is going to receive the light on a later time. That means to say that depending upon the time taken for the photo detector to receive the signal, I can say where my object is, whether the object is away from the sensor or whether the object is nearer to the sensor. Is this clear to you? Clear? Right? Yes or no? Right.
Yes, sir.
Yes, sir.
Second one will go to what is called as through beam type. Second one is through beam type. Okay, right. Now observe in through beam type. This is your LED. This is your photo detector. Okay, right. What is this? This is called as optical axis. What do you mean by optical axis? Optical axis is nothing but what? It is the ray of light falling from LED which falls on the photo detector. Clear? Now I will have the object now. Okay. This object, I will move this object and I will pass this. What is the effect? Okay, when I move this object here, let's say the object has come here. What is going to happen to the photo detector? When the object is going to block this line, what is the output in the photo detector? Huh? What is?
There will be no output, sir.
Okay, now simple. Okay, now photo detector will receive the light in all the time. Okay, photo detector will be receive the up line, receive the thing all the duration whenever there is no object. If the object is going to cross, what is going to happen now? It means that there is some interruption. Okay, some interruption is there. Photo detector, in this case, photo detector will not receive the signal. Okay, will not receive the signal. Okay, are you understanding? So this method is called as the through beam type. In through beam type, are you detecting the presence of the object or are you determining the distance? Straightforward question.
Presence of the object.
Okay, by using through beam type, you are detecting the presence of the object. Okay, right. So these are all the different types of proximity sensors. Okay, now I will just sum up. Okay, summary of proximity sensor. Okay, what is the first one? What is the first one? First proximity sensor is what? Tell me. Proximity?
Sir.
Huh?
Switches.
Proximity switches. Okay. Then second one was what?
Eddy current type proximity sensors.
Okay. Eddy current type proximity sensor. Eddy current type proximity sensor. Okay. Third one.
Pneumatic.
Pneumatic type proximity sensor. Then fourth one.
Capacitive type proximity sensors.
Capacitive type proximity sensor. Fifth one.
Photoelectric proximity sensor.
Okay, photoelectric. Okay, right. Now in photoelectric, we have two specifically. One is reflective, correct? Second one was through beam. Okay, right. Now just observe. These are the types of proximity sensor we have discussed. Now, what is the objective of the proximity sensor? I just want to give you a clear picture. What is the objective of proximity sensor? The objective of proximity sensor is to detect the presence of object. Yes or no? Is to detect the presence of object. Other one is to determine the closeness of the object to the sensor. Yes or no? Clear? Clear now?
Yes, sir.
Okay, now proximity switches is used for which objective? Quickly. I don't have time. Proximity switches.
Loads.
Okay. It is for what? First one or second one? sorry. It is used, first one, sorry. Okay. Proximity switches is used to detect the presence of the object. Then, but eddy current type proximity sensor, pneumatic proximity sensor, capacitive type, all three are going to be used to detect what is the distance. Correct? Now, in case of reflective is used for what? Reflective is used to again measure what is the closeness of the object. What about through beam type? Through beam type is for what?
Object, detect object.
To detect the
Presence of
presence of the object. This is used to detect the presence of object. Okay, now we have these many types of the proximity sensor. Okay, these many type of the proximity sensor which are going to be used and with this objective. Okay, so in the exam directly you may get a question on a proximity sensor. Okay, or you may get a question on proximity switches, eddy current type, pneumatic, capacitance, or the photoelectric type of the proximity sensor. Okay, so this is how the proximity sensors are going to be used and what are the objectives of the proximity sensors. Okay, now by which I completed this proximity sensor. Okay, so tomorrow when we come, okay, we will discuss what are called as the different types of the light sensors. Okay, is it clear now? Okay, so with this we'll close the session, and tomorrow we'll discuss the three different types of the proximity sensors. Okay, right. So we'll close the class now. Okay, so thank you.
Thank you.
You be in the same class. Okay, be in the same class. So let me stop the recording.